let's do a couple of examples just to touch base. All right. Now you can't see it. All right, so let's say we have an n value equal to 2, okay? What are my possible L values for this energy level? 0 and 1, very good. And what about my possible M sub L values here? And we got start with your first number. What about 0? What are my possible values for 0 going to be? Just 0. What about 1? -1, 0, and 1. Okay, we got our brains warm now. Now, what are my possible values if I have n equals 3, L equals 2? What are my values for this? I've now made a specific subshell here. So what are my possible M sub L values here? If we only got 2, what are they going to be? There you go. So again, M sub L values are negative L to positive L, including 0. Okay, it's that range here. Now, if I had n equals 4 and L equals 4, first of all, is that possible? Why not? Why is that? Why is L equal 4 not possible? Because L values are equal to 0 all the way to n minus 1. So if n equals 4, can we ever have an L value equal to our n value? No, we cannot. Okay. What letter is represented by, or what letter represents 0? What letter represents 1? 2 and 3. Do we really need to worry about any other letters besides these 4? We do not. Okay. How would you, what designation would you get if you have n equals 3, L equals 2? 3D. Again, because whenever you do the designation, you put the n value first, and you put the letter that represents the L value right after that. Questions on stuff from yesterday? Okay. Just want to do a quick review there. And now we'll get into our notes. High five, Mr. Dorf. I can't do this. There we go. All right. All right. So we are going to talk more today about our 4 orbital types, S, P, D, and F. Okay. So we're going to talk about the shapes, and those shapes are going to play a big role in the spatial orientation of electrons. Let's talk about our s orbitals. First of all, why do you think they call it the sphere orbital? Why do you think they call it a sphere orbital? Starts with an S, and look at its shape. What shape is it? It's a sphere. Looky there. So these section 6 is a really good section to go over the values and the shapes and everything like that for these orbitals. So again, we call it the sphere orbital. It has an L value of 0, as we just did. The radius of the sphere will increase with the value of n. Again, as we progress into larger values of n, we still have s orbitals present on each energy level. Because you can imagine, you've got all of these orbitals that are being piled on top of each other. So we're getting much larger, and we're getting much larger in a three-dimensional aspect. As we see here, look at the size difference, 1s, 2s, 3s. We're continually getting larger the more electrons we have at that particular energy level. Now, as we get further and further, where we go 1s, 2s, 3s, we look at these graphs of probabilities. Now, these graphs of probabilities of electron versus distance from the nucleus, we start to see these things called nodes in the s orbital. And they say n to the -1 nodes, or regions where there's 0 probability of finding an electron. So as you see here in this graph, 1s, high probability of finding an electron at 1s. 2s, okay? We have this distinction here between 1s and 2s. We have this little node right here where there's 0 probability of finding an electron in that location. So if you think about it, think about what Planck was saying, okay, where he said that energy is more like a staircase than it is a ramp. And on a staircase, you can't exist between steps. You can only exist on one step or another step or another step. That's pretty much what's going on here. We have allowed energies for these electrons to be present at, and in between those allowed energies, they could not be present. So we're starting to see Planck and his notions kind of being brought in a roundabout way to these new orbitals. Next, we have the p orbital. We call this the dumbbell orbital. As you can see, it looks like a dumbbell, okay? Each one of them has 2 lobes. Now, we said that P is equal to an L value of 1, right? What were my M sub L values for 1 again? How many numbers did I just write there for M sub L? 3. Looky here. 1, 2, 3. This one's just giving you density probability. These are the 3 different orbitals for P. You notice this one is vertical. This one's going along the x-axis here. This one's going around this y-axis here. Okay. What do you notice about the directions in which they are oriented? Are they all the same? No, they're not. They're all different. Now, this is something you need to remember, maybe for a test, okay? Where you have PZ, PX, and PY denotations here. This simply just means the axis that that particular p orbital lies on. Okay, so PZ, PX, PY is the axis upon which that particular p orbital lies on. Next, you have the d orbital. This looks kind of like a cloverleaf. Okay, again, the value for L, where d orbital is 2, meaning that there are going to be 5 d orbitals. Again, it's all based upon how many M sub L values you have. Now, 4 of the 5 d orbitals have 4 lobes. So here, 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 and here. That 5th one's a weirdo. Okay, it looks like a combination of a p orbital with a donut around the center. That's really the best way to describe it. So you got to imagine the more spatial orientation that is being taken up, the more creative that we have to get in order to place those electrons in outside of the nucleus and as far away from other electrons too, because electrons being charged with the same charge don't like to be next to each other, really. What do we know about particles with similar charges? They repel each other. And so they will try to orient themselves as far away as possible from other electrons. Then lastly, I don't have a specific slide for the f orbital, but down here on the very bottom is what they kind of render the f orbital to look like. Now, there's some contention that the f orbital is actually too difficult to draw, although, you know, I have found this slide where it does give some examples of where, you know, what they expect it to look like spatially. So again, we start off very simple with our s orbital, and we get pretty complicated and complex the further down the periodic table we get. Okay. Now, I mentioned yesterday that those 4 letters are going to come into play here pretty much for the rest of the chapter. And it comes in this form. Did I ask you if you've done electron configuration before? Okay. You remember doing electron configuration? Maybe an intro, or if you just took Chem 202? You know? We have 1s2, 2s2, 2p6, anything like that? Oh, well, we're going to do it. And what's nice is your table, your periodic table, is going to be set up in such a way that we utilize those 4 orbital types. And so we're going to spend quite a bit of time doing electron configuration when we get there towards the end of this chapter. Now, over the last chapter and a half, 2 chapters or so, I do this every year. Just a friendly reminder that we are going to be getting a little bit away from math, and, you know, just to make sure that when we do encounter math again, which we will, that whenever you provide an answer, that you provide a label. And I did my next slide kind of based off of our last quiz, because a lot of points I found were being missed simply by not putting a label at all, or not putting the correct label. So, if you can't see, that is Severus Snape. And so you have students ask, how many years have you been teaching? You know, if you were to ask me that, and I say 8, and I say, 8 what? 8 apples, 8 bananas? So make sure that we all try to abide by this little meme here. Always label anything that requires a label. Okay? Anyway, that does it for today. That is all we are going to do. Next, though, comes homework. Make sure you put your name on this. You will be turning this in to class on Tuesday after we go over it. Now, if you have any questions or just want clarification on, you know, what the question might be asking, feel free to come up and ask me, because it could be maybe not 100% clear on what the question is looking for, and that's no problem. So I will be glad to assist you with that.